Hi folks, welcome to my 8-Bit Retro Journal. Today I'm going to be playing around with my Timex Sinclair 1000. I've got two of them. I've got one that's not in a case, and this one actually, its ULA chip is one of the older ones, so you actually need to do a mod on modern LCD TVs because the picture is not as bright as it could be. This one actually is much better. And works actually kind of nice on my LCD TV. However, when I plug in a 16K RAM pack, the picture starts getting really distorted. This is one of the older two-board varieties, and I've read that can cause that issue. And I've learned that if I take the back cover off, the picture actually, heat dissipates quicker and the picture actually stays a little better. So heat's part of the problem. I read on a forum that one way to potentially fix or help improve the picture quality is via a better power supply. So this is the original DTE or DVE power supply that came with the Timex Sinclair 1000, again an American model, and it has it's 9.75 volts at 650 milliamps. And what I've read is that if you can increase the amperage, so the current that the computer can draw, that can improve the picture quality. Not sure why, but that's what I've read. And adding amperage doesn't necessarily hurt the computer because it just allows it to draw more. It doesn't necessarily. It's not like adding voltage, which could hurt the device. And then I found this power supply recently. It's a 12 volt. I don't know if you'll be able to read it or not. It's a 12 volt DC power supply with 1000 milliamps, which is equivalent to 1 amp. Of course, it has the wrong connector to it, but that's an easy fix. I have one of these. Connectors that you can create your own with. And so it's an 8mm jack monophone, and so I can use that. But the voltage is wrong. So the voltage on this is actually 12 volts. And so I've also read that you can reduce the voltage by using a couple of resistors. The easiest trick is to take two equal resistors, put them in series, and then if you grab the voltage, and you put that on the middle rail, not the ground, but the middle rail, and then if you grab the voltage between the resistors, it actually will have that. So it's a ratio. So if you have a 10 ohm two 10 ohm resistors, then it's the ratio is between the first versus both, so half, and it'll have that. And so if you have the right resistor values, you should be able to drop down 12 volts to 9 volts, and that's what I want to do today. I have a bunch of resistors. Unfortunately, and this is probably true for all of us, I don't have an entire resistor collection, so I've got these half-watt ones, but I only have 3 of them. They're 150 ohms, and it won't quite be enough to do what I want to do. If I actually, so this ratio, one thing you can do is if you have multiple resistors, you can actually put them in series. So if I want to drop the voltage from 9 to 12, I want to drop it by a quarter, and so if I had 4 of these, I could go 1 over all 4. That's a quarter. I'm going to go on the computer and show you the formula and do a little bit of math just to sort of prove it to you. But unfortunately, I have 3 of them. These are nice half-watt ones, so they can do a little bit better so these are the medium-sized ones. These kind of look robust, so I don't know if they'll work or not. And I've got a bunch of these, and I think I have the right resistance ones where I can do that. So these are, and then these are similar. They're hard to pick up. These are similar in size. And then I have these tiny ones. This is a 75 ohm one, and it came from a cable. And I took this one out of the cable, and I don't know if you can see it or not, but and I have a bunch of 75 ones, and I think, and there's a couple of 150 ones on as well. So that actually is workable. And what's nice about this size is that I can actually stick them inside of this and make it just inside the plug. I'm worried though that they're too small, so they're probably one amp's probably going to fry them. I don't know about these, so we'll see how it goes. But anyway, so I want to try to build that circuit for this and use this plug as my plug. And then finally, I have one of these adjustable ones, so you can, again, not sure if you can see it or not, but it can go all the way from 3 volts to 12 volts, and I have it set at 9 volts. This is only 600 milliamps, so it doesn't actually improve upon this. But I believe these tend to be regulated power supplies, meaning that they'll keep their voltage, whereas I actually measured the one that came with the Timex Sinclair 1000, and it measures at 12 volts. But I bet that as soon as I plug it in and it draws power, it drops down to about 9.75 volts, because unregulated power supplies only are rated when they're being used, not when they're unused. I don't know if this is regulated or unregulated, but this is, I think, is regulated, and I'll play with that as well. So so that's what I want to do today, and see if I can improve the picture of my Timex Sinclair 1000. So so that's what we're going to do. Okay, so I have found this website, and this says how to reduce voltage with resistors. And I think this picture and this formula below kind of demonstrate that. So again, this would be the tip that you going from 5 to 2.5 volts, and then you have another equivalent. So if you're trying to have the voltage, another equivalent resistor, then you go right back to ground, and then you attach an additional ground wire from the device. They attach here to ground, so they share ground. So that's the harness that I'm going to build. Except I don't want to do 2.5 volts. I want to do 9 volts. And so they talk about this ratio here, and you have R2 being this resistor. You multiply your voltage and then divide by both resistors. And again, I found this other site that kind of clarifies. This one actually talked specifically about what I wanted to do, 12 to 9 volts. And you can see right here, it says to reduce the 12-volt circuit to 9 volts, place 2 resistors in series within the circuit. Find the difference of voltage, which is 3 volts, to determine the total amount of resistance needed. Take that figure and compare it to the total desired output voltage, 9 volts. This gives you a 1 to 3 ratio. So which means that this resistor needs to be 3 times that of the first resistor, is basically what they're talking about. And ratio doesn't work as well for me as in terms of fractions. So if you look at this one, it's 10 over to combine both 20, so that's half, so you're having the voltage. So I want to get 3/4 of the volt while having the voltage, right? So I want to reduce the voltage by 1/4. So what I want is, in this case, I want a 10 ohm and a 30 ohm, kilo ohm. So that's your 3 to 1 ratio. And so let's actually do that in Notepad, just to highlight that a little bit. So if so this says R2 should be 3 times R1, right? So if R2 is simply 3 and R1 is 1, right? So that makes it, and then V in equals 12, and V out, which is in this diagram below, VR2, equal to 9, then we basically have the formula 12 times 3 for the top portion, divided by the total resistance for R1 and R2, which is 1 plus 3, which ends up being equal to 12 times 3 is 36, divided by 4, which is equal to 9. So that's what we get. We can, so as I said, a lot of times we don't actually have the kind of resistors that we need. But if you have one of a kind, so let's say I have a bunch of 75 ohm resistors, I can do it with a single resistor by just doing it in series. So the formula then looks something like VR2 equals, and if we do the top portion of this, we get Vn times three times the R1 resistor over R1 plus 3 more R1s. And that works out to be 12 times 3 times 75 divided by 75 plus 3 times 75, which is the same as 12 times 225 divided by 75 plus 225, which is the same as 2700 divided by 300, which equals 9. And so I actually have not only do I have enough 75 ohm of those little resistors, but I actually have a couple of 150 ohms. So I can actually do the different formula where I do a 75 plus a 150. So I can do it in series, and so that'll work. So in other words, you can sort of build these up if you need to. And then for the second set of resistors, what I have is I have R1 is equal to 20, and I have R2 is equal to 62, and that is going to help me create the same formula. VR2 is going to be equal to Vn times 62, and so then I get 20 plus 62, and that is going to, oops, doing this in Notepad, it's a little tricky, but doable. So that equals 12 volts times 62 ohms, and divided by 82, which again is going to equal, so 12 times 62 is 744 over 82, and that is going to equal 9.07. Let's see if I get enough space here. 7. All right. So if we do the math on that, I did that ahead of time. 744 divided by 82 is equal to 9.07, right? So that'll work as well. So that's what I'm going to try, okay? And so let's build that harness. All right. So soldering is always fun. Let me unplug that. So this is actually an old soldering iron that I probably had it since I was a teenager. I like it. It's pretty simple. It just has two settings, 15 and 30 watts. And but you can't actually turn it off. So I'm always worried about leaving it plugged in. So I have this timer where you can actually just set it to, usually I set it for an hour and it'll tick down and automatically shut off. So that's a nice little thing to have when you're using something like that, because you're not going to leave the soldering iron on. Okay, so I built these two harnesses. So the first one is using the smaller resistors, and so this is live and this is ground, and so again 75 to the tip, and then 75 and 150 gives me 225, so that's the 75 over 300 ratio. That'll step this down from 12 to 9 volts. And then the same goes for this one. Right, so this goes to the tip. And this is 20 and this is 62, so 20 over 82 is about a quarter, so that should also step it down. So anyway, so those are the two that I built. These are bigger, so I'm hoping they'll work better. And then I have this, as I said, I soldered on blue for ground and red for tip that I'm going to use as a test for testing, and the TV actually just shut off. And so let me put this in here, and I'm going to close it up so that I don't short anything. Okay, so blue, brown, red is going to be the tip. Okay, so let's first, so this is the original, and so how can I need to prop up my voltmeter so you can see what I'm doing. So let's see if I can't prop it up a little bit. Maybe put these under here too. There we go. So you can kind of see what's going on here. I like this old multimeter. It's just analog, and I've just really gotten fond of it. I had this for a while too. The modern ones, I mean, they're based on the same principle, but they're able to do more. So this one, for instance, isn't able to read current, but I've read the way you can read current is you have to add a resistor in between the power source and then read the voltage drop or the voltage across it, and you can compute the current. So those modern multimeters are just kind of playing with Ohm's laws. Okay, and again, I'm not an expert in this area. So anyway, I have all three power supplies plugged in. So this is the original one, and if I measure this, so black is going to be my ground, red is my tip. That you see that it's, if you can't see it, it's 12 volts. But I bet as soon as I plug it in, it's going to drop the voltage. So again, it's the furthest plug is the power one, closest to this transistor. And you plug it in, and you get the picture. So it's a very dim picture. So this little LCD TV does a better job than others, but this is an old ULA, so it doesn't actually help you get the. It doesn't have the backport signal that's missing. So if I measure the signal off of this, it has now dropped to about 10 volts. Yeah, which is what I expected. I'm going to remove my soldering iron, which I don't need. I'm going to plug in my, I'm going to unplug this, and then I'm going to plug in my there we go. And then I'm going to plug this back in. I just want to see what the power drop is when it has the 16K RAM pack. So a little less than, so it was a little above 10 volts. Now it's a little less than 10 volts. So yeah, that's kind of, so this, the original Timex Sinclair 1000 power supply is what's called an unregulated power supply. Okay. So, and again, if I measure this, it's black on ground, red on tip, and it's... All right, so I'm going to start with this, this connector, and I'm going to connect the smaller resistors, because I'd really love to use those inside here. I don't think it's going to work because I think it's not going to be able to handle the 1 amp, but why not try, right? So this goes, let's actually hook it first to this. So I tried to be color coded. I ran out of blue, so it's, by the way, I use this telephone wire. I find this very nice. It's easy to take the sheath off, and it's copper, and you can do soldering. So I use this all the time for my project wire. So I want, this is the tip, I mean this is the ground, and this is going to go to the tip. Alright, so let's do that. And I have a little bit of shrink tubing that I'm going to use to cover up the ends so that I don't get any shorts. The wire heats up, this will actually shrink over it, but hopefully the wire is not going to heat up and I need to do a better job on this one. And again, I'm just going to use the other end of it, but it's actually not going to, yeah, there we go. Cover it up so nothing happens. So here is my tip, and then I can just kind of bend these a little bit. And so, so this is going to, so I've already manufactured this so that it goes to the outside, and then this goes on the inside. And then let me measure this. So this should be, again, black to tip. And yeah, it's about a little under 9 volts. And again, you might not be able to see it, but the needle is under 10 volts. So 12 volts is more than almost 3/4 of the way. The needle is under the 10 volt mark, so that's nice. Okay, and it's positive. Yep, positive tip. I'm just going to double check that. It's always good to double check. Yep. All right, so I'm going to plug this in and see what happens. And I get no signal whatsoever, so let me actually measure this. And it only gives me about 3 volts, and oh yeah, they're getting very hot. So I'm going to unplug this. So these are just not big enough to draw the current. They were, you could really, this one especially was getting really hot, and it was only giving me about 2.5 to 3 volts, so not enough to drive the signal. So this was not successful. All right, let me undo this. All right, so the small ones, which would have fit nicely in here, just too much amperage, I think, is occurring. So let's undo this and do the next one. Okay, so here we go. So that test harness is done with. Don't know if I destroyed any of the resistors, but you know, they were free to begin with, so I'm not too worried. Test harness number 1, no good. So here's my second test harness. More robust resistors, so the same thing. So this time blue on blue, that's my ground. All right. Red on red is my live, or the actual voltage going in. Once again, sorry if I get off screen. The camera's in such a place it's difficult because I'm trying to get the TV as well. So I'm going to have this over here, again over here, just so to avoid any potential shorts. All right, so once again, this is my wire. So this is going to go, one more time, this is ground, and then this is the live one. If I bend it out a little bit, it's going to stick in there better. There we go. All right, so I'm going to measure this once again. So, and again, it's right under the 9 volt mark, which is again what we want. So I'm just going to always double check. Black, yeah, that's 12, so it's positive tipped. Oops, I think I just removed it. So this part came out. Let me just make this a little bigger. There we go, so that it stays in. There we go. So one more check on that. So yeah, nice. It's 9 volts. It's actually yeah, just 9 volts. Exactly where you expected it to be. So again, I'm going to plug it into this one. Just make sure that it's not. I'm worried if these things overheat. I don't want it to like start melting something. So I'm going to plug it into this one. Oh, it's got a signal, but it's not. Now it doesn't have a signal. So let me check on that. Yeah, the same issue. It's 3 volts, and yep, they were getting hot. So again, it's actually this one, the one that's on there, that's getting really hot. So it just can't deal with the current. So that's a no-go. That was a good try. Ooh, it's definitely hot. So that also didn't work. Okay, so unfortunately, even though I'm able to cut the voltage, I don't have the these resistors are just too tiny for them to be able to handle the current. That's my conjecture. So let me. That's one thing I want to find out. So let me see if I can search for that to see what's going on here. So I found this website on resistor power ratings, and it's pretty helpful. And in fact, if you go scroll down, there's a formula at the bottom here that lets you figure out the amperage given the ohm and watt ratings of a resistor. I remember I had those 3 package resistors that were half a watt and 150 ohms, and so if you do that formula, let's see what they could take. So they were half a watt point. So I'm going to have to actually use a scientific one. So they were 0.5 divided by 150. Whoops, 150. And then you take the square root of that. And so they could take only about 50, 60 milliamps, so not that much. So I think the simplest thing is to grab, if you get a 1 watt resistor and you have it be 1 ohm, that's 1 over 1 is 1, the square root of 1 is 1. So that actually would do it. Or anything that's, anything that's smaller, where the wattage is higher than the ohm rating. You can get 2 and 3 watt resistors too, but it seems like 1 and 1. And I did find for 335 you can get a pack of 10, and they give you 1 ohm resistors at 1 watt. And then I also found this, you can get them below 1 ohm. So these have a half a watt, and you can get them at 33 ohm. So there you get 4 of these, and you can go and or you can get you get a 24 and a 70 and a 75, and you have the same ratio. Or you can just get 4 33 ohm ones at 1 watt, and I think that would solve it. So I might order a set of these. They're pretty inexpensive, and you get 10 pieces just to see if I can get that. And this is coming from the US, so it shouldn't take too long. So I might give that a try. So the other thing I wanted to try is, now I have this this switching one that I believe it's regulated because it can handle different voltages. So I bet that this one will keep its 9 volt rating. So let me give this one a try. And so again, I can use this one again. I don't know which one tip. It doesn't tell you which one of these is tip or not. So let me straighten this out. So in case I was off camera, I'm going to try this one, and I got to figure out which one's tip. So I'm going to bend these here. I think it's the easiest way to do it. Bend them here, and I'm actually going to use this shrink tubing to avoid any shorts. All right, and so let's see if I get it right on the first try. So I'm going to put plug that one in here. Oopsie, it's hard to plug it in. I'm actually bending it, but there we go. And I'm going to plug. Oh, it's coming out. All right, I'm going to plug that one into here, and I'm going to plug that one into here. So hopefully, again, just to avoid shorts, let's see if I got it right. Now I got to redo it. So, yeah, I got it wrong. It's okay. So, I need to switch these. So that one needs to go to that one. Here we go. That goes there. And this one goes to that. Oop. There we go. Plug them in. Make sure that this is in there solid. And then, so we don't get any shorts, cover that up. And do the test. And yep, 9 volts. Okay, so that's, again, always double check. Yep. 9 volts. Good. So I'm going to plug that into this one. Monitor's about to shut off, so not on my watch. Okay, so yeah, it's getting a signal. It's not bad or good, it's just a signal. The so let me try it with the all right, let me move this out of the way. So I actually want it. There we go. So I'm going to put the RAM pack on because it does change the oh, one thing I didn't do. Let me plug this back in. I get a picture, and now let's see what the power draw is. Yep, 9 volts. So as I thought, this one is a regulated supply. So I'm going to do that, and I'm going to plug the just to see if it draws more power and how the picture ends up being. So if I use this, let me use the original one first, again, just as a comparison. So the picture is really crappy with 12 volts. On this one particularly, on this particular board. So if I remove that and I add this one, it's just as crappy. Yeah, different interference pattern, but it's just as crappy. And again, this is just the back is, you know, whether or not it overheats or not. Yeah. So it's pretty crappy. I don't know if you can see it on the camera or not. Okay, and the power draw here is, it's consistently 9 volts. So again, that's a nice regulated power supply. It's 600 milliamps only, so it's 50 milliamps less. Okay, so what I want to do next is I'm going to put this one to the side, and I'm going to have, so I have my other one, which is right here. And so I'm going to use that one. And you'll see right away that I'm going to put this one to the side here. You'll see right away that this one has a much better picture. So we're going to try first with the original power supply. And you'll see the picture is going to be gorgeous. Look at that. Nice and crisp. Almost... This is not in there right. Nice and crisp, almost no interference whatsoever. Now that unfortunately changes as soon as you put this RAM pack on. Once you put this RAM pack on, let me make sure this is on there tight. And if I put this power in here at the 9 volt mark, I don't know if you can see that or not, at the 9 volt mark, that it's definitely has less interference than the other board, but it will. In fact, as I leave it plugged in, this starts becoming really wavy, and that's the thing. If I take the cover off, then it gets less. So, but let's try my new one again. Let's make sure this is still. So this is 12 volts. This is 9 volts regulated. Let's plug that in. And yeah, it gives a similar picture. So what I'll do is I'm going to let that sit for like 10-15 minutes to see if the picture actually improves or not, and to see if I can if that has an impact or not. It'd be interesting. So and I don't know if it would be because it's a regulated power supply or because it's less milliamps. Again, I read more milliamps, more amperage would be better. But so I'm gonna leave this plugged in, and I'm gonna come back to that. All right. Well, I've had it plugged in for about 25 minutes, and the picture, it's gotten worse, but And sometimes it gets wavy and then it sort of settles to this. So it's actually, I don't know, I think it's adding less interference to the, yeah, so if I press it down like that, so if I do that, that's usually the interference pattern I get. Oh, so now I have it. So maybe it's just the way it's connected. Yeah, so maybe it was just, yeah, so if I plug this one in its place, that's very similar. Yeah. Well, anyway, the regulated one was giving me that at times, and then it was kind of settling down to it. But it's also the way this is sitting now. Really, the more important thing is not that it was consistent for 25 minutes, but how does it act once this thing is overheated? And I don't have a rubber band, unfortunately, to keep this closed. So if I, again, the original power supply, yeah, that's sort of the interference that I expect. It's very wavy with things going up and down. Again, if I take the cover off, it'll slowly cool down and get back to much more normal self. And if I try this one, see, so it is different. It gives me less of the wavy stuff, and it's a bit more settled down. So maybe the regulated versus non-regulated is a difference. So anyway, yeah. So this is definitely right off, without having touched that. The picture is much wavier and worse. Whereas if I try the regulated one, yeah. So this is actually a better picture. Now if I wiggle that, it'll start getting interference again. I'm not sure why. Maybe it's losing contact and it has to readjust its voltages. Again, I'm not an expert at that. But at this point, the regulated one, so it's 50 milliamps less. So it could be the milliamperage, or it could be the fact that it's regulated. So I'll have to play more with this in the future. But if any of you watching this have any idea of why, I'd love to hear it. So leave comments below. But anyway, so that's been my little experimentation with trying to see if I can improve the picture on the 16K ramp pack. I think the other thing I want to do in the future is maybe add a little mini fan in here, because again, as soon as I take the cover off, the picture improves. So I get rid of these wavy lines with the original power supply. But maybe I can also sort of locate a regulated 9-volt one, or create a permanent plug for this one. Plug for this one. I don't know if they make these kind of plugs for these, tipped. These are pretty standard power supplies that work on any device, but I don't know if they make an 8mm jack for these. I'll have to search for that. That would be kind of nice. But yeah, so that's it for today. Thanks for watching, and stay safe.